Theorem 1. A straight line drawn from the center of a circle perpendicular to a chord bisects the circle. Bisects the chord, sorry. Bisects the chord. Let me take it again. A straight line drawn from the center of the circle. This is the center. Drawn from the center of the circle perpendicular to a chord. That means from here to meet this chord. Perpendicular. A perpendicular line means two lines coming together to give you a 90 degree. That means we use this symbol oftentimes when this line and this line joins meets, then you have a 90 degree. So it is called perpendicular line. So when it cuts this chord, when it gets to this chord, when it gets to the point of point here, it becomes a perpendicular line. Then this line becomes a perpendicular line. But what this theorem is saying is, once we have this achieved, like I've explained, it will bisect the chord. That means this side will be equal to this side. So if this is 5 centimeters, this will as well be 5 centimeters. Then the entire chord will be 10. So that is what the theorem is saying. Let me take it again. When you have a line drawn from the center of a circle to meet a chord, note, you can have a line from the center of a circle to cut the chord here. You can have a line, but this particular one, it will be a perpendicular line. If it must be a perpendicular line, then definitely, without any argument, without any argument, this side will be equal to this side. So if this one is 10, this will be 10. If this one is x, this one will be x. Then we have the entire line to be the entire chord to be 2x as we can have it. That's that. Let's check some examples now. AB is a chord of a circle. The radius of the circle is 13 centimeters. And the distance of the chord from the center of the circle is 5 centimeters. We are now asked to find the length of the chord AB. That's the first question. And we should find the angle subtended at the center of that circle. Those are two simple questions we were asked to solve. Let's see. To solve this, I will need a picture. This is my circle. Of course, I have my center. So from here, I have the chord. My chord AB. Let's say my chord here, A and B. Then I'll have my radius, 13 centimeters. 13 centimeters. I can as well have my radius here, 13 centimeters. So, and the distance of the chord from the center of the circle is 5. So when we have this distance, which is perpendicular, like we've said, it is 5 centimeters. So we are asked to find the chord of AB, and the angle subtended at the center. That means this angle. Those are the two questions. Let's see how this works. I think, looking at this question, it looks like we already have a solution, because this is 13, this is 5, this is 12. This would definitely be 12. That's from Pythagoras triple. Pythagoras triple will give us this when we have 12, 13, 5, and definitely we have 12 here. What does that mean? If we have by Pythagoras, whereas we have let me put O here and M here in the middle. So OA, which is your hypotenuse square, will be equal to AM square and OM square. You all know this theorem. So once we have this, we know this to be 13 and this to be 5. So our OA, that is 13, will be powered. Then AM, we don't know our AM, so we rewrite it AM then square plus OM, that is 5. That is 5 centimeter square. So this one gives us 169 perfect square. Then we have AM, this square, that is plus 5 centimeters, that is 25, sorry, 25 That's 25 if you power 5. So we send this one to this side. We have 169 minus 25, which will give us our am square. So we subtract this. This should be 5 from 9, that is 4. 2 from 6, that is 4 as well. We have 1, that is am square. So to remove this square, definitely we have to root the two sides. That's the theorem. To remove a square, we root. To remove a root, we square. So we root this and we root this. So root of 144 is 12. That is am. Don't let us forget how I got my 12 even before this theorem. There is something called Pythagoras triple GSS3 that tells us that if you have 3 or 4 and 5 as our background, then we go this line, then we can go 6, 8 and 10. What am I doing? I will add 3 to this, I will add 4 to this, I will add 5 to this. So if I add 3 to 6, I will have 9, add 4 to 8, I will have 12, and this will be 15. These are Pythagoras triples. Likewise, we have another, once we have 3, 4, 5, we can have 5, 12 and 13 too. So this one follow this trend. We have 10, we have 24 and 26. So if I have my side here to be 10 and I have this side to be 24, definitely it's going to be 26. That is how I got to know these things. So they call them Pythagoras triple. So now that we know that this one is 12, we have gotten our length. So the length of the chord now will be equal to 12. That means this in two places. Definitely don't forget this one is the same thing as this. So it's going to be 12 in two places. That is 24 centimeters. Remember the theorem that says once we have this as a perpendicular, whatever thing we have here is what we have here. So to get the length of this chord, then we have 12 plus 12. That is 24. That is for the first question, which is the length. Now, going for the angle subtended at the center of the circle, going for this other question, that means I think I can solve this first. If I solve this, we are looking for this angle. If I solve this maybe by SOHCAHTOA, that is by trigonometry, then I will double it to get the entire one because this one is the same thing. So this one is the same thing as this. So once I get this one, I will now multiply by 2 to get this. So to get this one, I will have opposite over hypotenuse or adjacent over hypotenuse, whichever one, but I will prefer 5 against 13 in case, mathematics student, probably this your 12 was wrong, then you shouldn't be wrong here so that you won't have 0 in all your in the entire question. If this is actually not 12, maybe you made mistakes or something, and you have used it, then you have a problem. So I would prefer to use what I was given to solve my work. So let me quickly solve my work here. From here, I have adjacent against hypotenuse. That is cos. My cos alpha will now be 5 over 13. So I will have cos alpha to be, this one will be 0.3 according to calculator 3846. And if you arc sine this one, that arc cos, that is arc cos of this one, you of 0.3846, your cos, your value will be 67.4. That was what I got. So if this one is 67.4, therefore the entire angle, let me call it theta now, will be 67.4 times 2. To multiply this one, 4 times 2, we have 8. Then this one we have 14. That we have 4. Keep 1. This is 12, and we have 13. So this is the angle we were asked to solve. Let me explain this again in case you are confused or something. This is a trigonometry. We are going to discuss trigonometry, but if you think you need to learn trigonometry itself, just communicate with me through the number that is scrolling, so we will immediately address the case. But in case you are confused, there's something called SOHCAHTOA. So this car is telling us we are solving cos against adjacent over hypotenuse. One of my students will say ADJ over HPY. So we have this. This was what I used to get my value. That is the answer to these questions. Let's check another example. Let's start again. Traffic. A question says, look at this question. For this question, we have the center. But there is we were only given reflex AOB. That means this angle is a reflex angle. Reflex OAB to be 264 degrees. Then we don't have the OAB original, so and the question asks us to find the radius of the circle, which is R, which is the same thing with this, and we as well asked to find the length of this chord. Of course, if we get this, we will double it like we did the other time. But how do we start this work? How do we start? I have an idea. If you have this side, this angle, that is this original angle, that's AOB, then we can divide it into two to get this alone. So once we have gotten this, we can then use our SOHCAHTOA to get our radius. That will be adjacent against hypotenuse. Then we can get our radius. We can as well use it to get this one, or Pythagoras theorem to get this one. Then we double it. What am I saying? Let's get to work. How do I get this angle? How do I get this? This is a circle, that is angle at a point. So if I have 360, that is angle at the point, minus 264, which will give me, let's say this is 10, 4 from 10, that is 6. Then this remains 5, that is 6 from 15, that is 9. Yeah, 96 degrees. While we have angle at a point, which is 360 degrees, so we have 96 degrees here. So once this is 96 degrees, we can divide it by 2, like I said, by 2. So 2 in 9, we have 4, remainder 1. In 16, we have 8. So this angle will be 48 degrees. Likewise, this was as well be 48 degrees. Are you paying attention? All right, let us continue. Once we have this, we can use SOHCAHTOA, like I said, to get this. So this will be adjacent against hypotenuse. Adjacent against hypotenuse. So that is adjacent and hypotenuse. That is A and H. That is cos. That is CA. So to have this, we have cos 48 degrees will be equal to adjacent, that is 18, over hypotenuse, that is R. So from our 4-figure table or calculator, cos 48 gives us 0.6691, then which is equal to 18 over R. So if we cross multiply, I will have 0.6691 R is equal to 18. Then my R will be 18 over 0.6691, which is equal to, from calculator, we have 26.9 centimeter. That is our R. Our R is 26.9 centimeter. So we have gotten our R. Once we have gotten our R, we can then proceed to get the length of the chord. So to get the length of the chord, it depends. We can use SOHCAHTOA. Once this is 26.9, we can use SOHCAHTOA to get this. That is SOHCAHTOA using 48 against this to get this. And we can as well use Pythagoras theorem that I used the other time, because we have this, and this. Of course, we cannot use Pythagoras triple here, so we have to work it out. But instead, I would prefer a SOHCAHTOA. We have x and 18, that is opposite. This is our opposite, this is our adjacent. Of course, this is the hypotenuse. So opposite against adjacent, that is opposite and adjacent. Remember, I wrote SOHCAHTOA the other time, SOHCAHTOA the other time. So to have this, obviously this is O and A, that is O and A. So I need a tangent. So to get a tangent, so I have tan 48, which is equal to opposite, which is x. I wrote x there, then against 18. So I have x is equal to 18 multiplied by tan 48. So 18 times tan 48 gave me 1.11. Using calculator, you can as well use your 4-figure table. Just check tan 48, then multiply it by 18. So I have 19.99 centimeter. So if I approximate this, I will have 20 centimeter. So once this is 20 centimeter, then the length of the chord, please let me come here, of the chord now will be 20 multiplied by 2. That is 40 centimeter. That is what we have there. So we have 40 centimeter as the length of this chord. Then we have 26.9 as our radius. We've come to the end of the work, but I want to give you classwork to see how far you have learned. Of course, it is important for me to see how far you have learned, but how do we get the feedback? Send your work to my WhatsApp page. Once you have been able to do it, send it to the WhatsApp page, or you make the comment below, then we will definitely attend to you. A chord is 5 centimeters from the center of the circle. You have to draw this picture. A chord is 5 centimeters from the center of the circle of diameter 26 centimeters. That means the diameter is 26. Obviously, the radius will be half of the diameter. That's 13. That's what you are using. So find the length of this chord. Draw the picture. Let me see how it looks. Then insert those values, solve your work, and send it to my WhatsApp page.